In this video I'm going to look at the 2017 higher level question B2. It looks at dihedral angles, traces and coordinate systems. So we'll just have a quick read through the question first. And the image on the right shows a playground unit incorporating two planar surfaces which intersect as shown to represent the bow of a boat. The unit also includes a triangular seat and two circular portholes. Figure B2 below shows the plan and elevation of a model of the unit. The horizontal and vertical coordinates of the two intersecting planes ABCD and ABEF are also given. So they're the coordinates on the right hand side. Part A of this is to draw the plan and elevation of the two intersecting planes ABCD and ABEF. Part B is to determine the dihedral angle between the planes, so the true angle between the two planes. Part C is determine the true shape of the surface ABCD. On the true shape include a 20mm diameter circle for the porthole, given that its centre is 30mm from the line AB and 50mm from point D. Now we only need to draw that on the true shape, not on the elevation or plan. Final part of this is the midpoints of the line AB, AD and AF to find the oblique plane which contains the seat. Draw the elevation and plan of the seat and determine and indicate the horizontal and vertical traces of this oblique plane. So let's get this question started. And for this we just need an arbitrary point, a random point off out to the left hand side of our page, which is where we're going to set up and start drawing from. So I'm going to keep my question up relatively high to the top left corner of the page, and I'm going to start my measuring from there. So I'm going to pick this point here as my datum for measuring. So point A is 205mm from the left. It's on the ground, so it has no altitude, and it is going to be 40mm out down from plan. So as I said in a previous video, the first coordinate is its distance left to right. The second coordinate is its altitude off the ground, so we'll see that in the elevation, and the final coordinate then is its distance out from the wall, so we'll see that one in the plan. B is 235, so again starting from the same point. 235 this time has an altitude of 60. And a distance down of 10. That's B. C is in 195. Altitude of 20 and distance out of 100. D is 185. On the ground, so that's D, and it's down 110. I just paused the video there to speed things up a little bit. So I found all my points. Now I'm going to draw the planes, the two planes A, B, C, D. So A, B, C and D will join together up in the elevation. A to B, D to C, and C to B. Second plane F to E, which also joins to B, so they share a common line, and F also goes to A. In our plan, E and F join together, just like they did in the elevation, which joins to D. to A and back to F. So A to D, D to C, and C to B. So having located each of those points, that is part A of this question complete. Draw the plan and elevation of the two intersecting planes ABCD and ABEF. Next part of this is determine the dihedral angle between the two planes. So they share a common line AB. So if I find a point view of that line, I will be able to see the dihedral angle between them. So if I need a point view of something, I need to find the true length of it first. So to do that, I'm going to look in perpendicular to that line. So looking in perpendicular to that line, I'm going to draw an x1, y1 line just out here somewhere, just out a little bit beyond the object. So this is my x1, y1 line, and I'm going to project the line AB out perpendicular to it. So A takes its altitude from the elevation, so A is on the ground. B has an altitude, as we saw in the question, of 60, so I can measure that height here, 60, and mark that up over here. So this is B. So this is the true length of the line AB. Now what I'm going to do is I'm going to take each of my remaining points, B, C, E, C, D, E, and F, and project them out here also, because I'll need them for the next part of this. So I'll just label my true length. That's the true length. So I'm going to project point C out, which also happens to line up with E, and point D out also, and they also happen to line out. So F and D are on the ground, so that's that point. So that joins to A, and point C and E both have an altitude of 20, so we can mark up those points here. That's C and E. C joins to B, and they also join to D and F. So that is what this looks like when I take an auxiliary view looking in this direction, which shows me the true length of the line AB. So I have the true length of the line AB and an auxiliary view of the rest of the two planes. What I need to do next, I'm going to look along the line AB. So that'll give me a point view of it. So if I look along the line here, I'm going to keep it as close as possible just so I don't run out of space. And this is my x2, y2 line. And I'm going to project each of these points out also. And they happen to line up here also. So, as this is an auxiliary, a second auxiliary, I have my view that I'm working from. I'm going to skip this view and measure from this view back here. So I'm going to take the distance from C to D. We'll start with the distance from AB, so measuring from our XY line back to the points AB. Now they're in line with each other, so they're the same distance back, giving us the point view. That's out along here. That's the point AB. I'm going to do the same thing for point C and D. They're both the same distance back, so this is going to be C and D. And also along that same line coming out, measuring back from my XY line, so I need to measure the distance for E and F. They're both parallel to each other, so E and F is going to be back this distance also. So C and D and E and F. Joining these up together, I have a point view of the true length line AB and an edge view of my other two planes. Therefore, I now see the dihedral angle. This point in here, this angle inside here, is the dihedral angle. So, just a quick recap on what has happened so far. I looked in perpendicular to the line AB and got a true length of it. Once I have a true length of it, I looked along that line, so I looked projected out from it. I took my distances from the skipping one view, skipping this one, measuring my distances back, so from my x1, y1 line back to the points AB, here and here. I did the same thing for the other points, CD, they're parallel to each other, so they come back here. E and F, they're the same distance also, giving me an edge view of the plane. So as I have the edge view of two planes and a point view of the line of intersection, that gives me the dihedral angle between the two pieces. So just looking at the question again, we've completed part B. Now for part C, determine the true shape of the surface ABCD, and on the true shape include a 20mm circle for the porthole, given that its centre is 30mm from the line AB and 50mm from the point D. So as we have an edge view, we can now rotate that surface around so that we're looking straight in at it. And we have the axis point that we can rotate it around also. So I'm going to do that down here. So I'm going to rotate this surface down so that it becomes flat, and it's going to come out this way. If you have more space on the page, or if you kept your x1, y1 line out further, you'll have more space up here to do it. So what we're going to do is we're going to rotate this down flat until such time as we'll be looking straight down on top of it, which is what we're kind of doing here. So if I can rotate this so that I'm looking straight down on top of it, I'll be able to see the true shape of it. All our points are going to move out perpendicular to the axis, so we're going to move straight out along this way. So I'm going to do that bit of it first. So taking our true length line as the line that as our axis point. So basically what's happening at the moment is we have our shape like this. It's leaning up at an angle. We're just going to flatten it down so that we can now see the true shape of it. So all points are going to move out perpendicular out along here somewhere, and we just need to figure out where they are out along there. So to help us with that, I'm going to put in another line that would be horizontal or parallel to the x2, y2 line, and I'll swing each of my points down around that. So if I'm to take E and F, they both swing down along this way. This is how far out they are in its new position. And I can now project that back down into the plan, or into this auxiliary elevation, giving me that point and this point. So this is D, and this is C. So the true shape of this, if I join A joins to D, D joins to C, and C joins to B. So that blue area here, including the true length, is the true shape of that surface. So all that we've done is we've taken an edge view of it, rotated it around so that we're now looking perpendicular to the top of it, and because everything rotated from being up in this position down flat, everything's just moved out perpendicular to it. The next part of this question, of part C, is on the true shape include a 20mm diameter circle for the porthole given its center is 30 millimeters from the line AB, so it's going to be 30 millimeters out from line AB and 50 millimeters from point D. So what that looks like in reality, 30 millimeter line parallel out along here, and we'll draw an arc that's 50 millimeters away from there. So I'm going to measure out here 30 millimeters. So somewhere along this line I will find the center for my circle. So everywhere on that line that I've just drawn now is out 30 millimeters from that point. So everywhere on that line, this is 30 millimeters out from that. What I'm going to do then is set my compass to 50 millimeters. And we're told in the question that it's 50 millimeters from point D. Point D is the one down here. So if I swing an arc now that's 50 millimeters from there, where that arc intersects the straight line is both 30 millimeters away from my true length line and 30 millimeters away from here. So now what I can do is I can draw a circle of radius 20, sorry, diameter 20, radius 10, diameter 20, radius 10, around that point that I just found. You only need to draw it in this view, you don't need to draw it in the elevation or the plan, it's just on the true shape that you're drawing it. So, this is on the true shape, so I've colored in blue. So that circle is on the true shape. It's a distance of 30 millimeters from the line AB, and it's 50 millimeters from the point D, that giving me the center. So the final part of this question is part D, the midpoints of the line AB, AD and AF. Define the oblique plane which contains the seat. Draw the elevation and plan of the seat, determine and indicate the horizontal and vertical traces of this oblique plane. So the first part of this, we just need to find the midpoints of each of the lines AF, AD and AB. So to do that you can just bisect each of the lines. So we'll bisect AF and AD in plan and AB in the elevation. So just extend over halfway. So find the midpoint. So all I'm doing is basic construction for bisecting a line. And that's going to give me my two midpoints. So there's one, and here is the other one. Finding those up in the elevation. Just going to project my lines straight up. So this is one of them, and the other one is over here. Finally, I need to bisect the line AB, which is up in the elevation. So I just extend over halfway, swing an arc, swing the same size arc to cut it. So that's the midpoint of that line there. Finding that in plan, it's going to be just directly below it, so just project that down onto it. Okay, so that gives me the plane, or the start of the plane, the projections of the plane. So just draw it in lightly first, because it doesn't touch the ground, it's up a small bit from it. So it's up 5 millimeters from that as given in the question. So that then is the bottom of the plane. So I can see this much of it. This part of it back here is hidden behind the other one, so that can be hidden detail. And same for the bits going up along here. I can see a small portion of it. Just the bit that's sticking out down there at the end, or this part of it up here then is hidden detail. So finding these same points that I just found there in plan, just projecting them down below from one view into the next. So this point is there, and the other one is on the line. So all I've done is I've joined my two midpoint lines together. So from bottom on the line AD up to the midpoint of AB, giving me the same line that I had up here. That point there is on that point, so it's going to be here, and same for the one on the opposite side. So this is the complete oblique plane that we were asked to draw. So there are the projections of the oblique plane, and that will make some of this in here hidden detail. Okay, so just quick recap on what happened there. I bisected each of the lines AF, AD and AB. As told in the question, the oblique plane is formed by the midpoints of each of those lines. I joined them up, giving me the oblique plane. Just watching the elevation, it doesn't come all the way to the ground, it's up 5 millimeters from that bottom point. And then we'll locate those points down in plan also. The final part of this question, of this one, is determine and indicate the horizontal and vertical traces of this oblique plane. So we have the oblique plane. We need to find where it intersects the vertical plane and the horizontal plane. For the horizontal plane, it's actually quite easy for us, as they kind of give it to us already. We have 2 points on the ground where the plane touches off the ground. So it touches off the ground here if it was extended, and it also touches it here. So if we extend this plane down until it touches off the ground, that gives us 2 points on the trace. So 1 and 2. So my horizontal trace for that oblique plane is this pink line. So all I'm doing is extending the plane on until it touches off the ground. And I know that the line AD is on the ground, and so is the line AF. So that is a point there, both points on the horizontal trace. To find the other trace, we just need to take one point that we know, and that's on the plane, and we're going to project it parallel to the horizontal trace in plan. So if I take the line, we'll take this one up here, the midpoint line, and the line AB. If I go parallel to the horizontal trace, the pink line that I've just found, from that point until it touches the XY line, I can then go vertically up at that point and horizontal from the same point, giving me my trace, or point on the trace. So that's that point. This line here is the vertical trace for that oblique plane. So just talking about that once more. The horizontal trace is found by extending the plane, making it longer until such times it intersects with the ground. We can see that up here, and we can also see it down here on plan, because we know that the line AF is sitting on the horizontal plane. So this point and this point are both points on the ground, and if they're on the ground and the oblique plane intersects it, they have to be points on the trace. So that gives us our trace. We extend on until it touches the XY line. To find any point, so if you look at the video on traces, if we have any known point, we can take a line parallel to it. So we're taking a horizontal cut through that top point. So another horizontal cut, just like this was a horizontal cut, will give us a line parallel to the pink line. So this one and this one are parallel to each other. We're just finding that same point up in the elevation. So if it's going to be directly above it, and this is that horizontal line, the horizontal cut intersects there, giving us that point. And that completes this question. So just zoom out slightly. And that is the 2017 higher level question B2.